So now, the next thing we want to do is sometimes we just want to know if something goes into another polynomial evenly without a remainder. So we have a remainder slash factor theorem that we can use that's helpful with that. And basically, if I have a function f of x and it's equal to x minus k times something like q of x plus a remainder, then we can we basically say that r is the remainder. Okay? All right? And so what we would say is that r is equal to f of x if it's divided by k. So let me write this out. So if the polynomial f of x I'm trying to think of a less formal way to say it. I'll just write it out formally and then I'll let you process it. If a polynomial f of x is divided by x minus k, then the remainder is equal to f of x. Okay? And so that may not make a whole lot of sense. So let's just try to apply this remainder theorem and then go from there. So what does that look like when we try to apply that? Well, let's start with an example. Let's start with a polynomial. Let's say that we are given f of x is equal to 3x squared plus 7x minus 20. Okay? And then it says find the remainder when this is divided by a polynomial. So what we want to do is we want to figure out what the remainder is when we divide it by x minus 2. So the first thing we do is we say if this is divisible by x minus 2, then that's a 0. So then x minus 2 should equal 0. So then x should equal 2, right? So to find the remainder, what we need to do is we say that if it's divisible, then the remainder is equal to f of x. Well, the remainder of f of 2 would be evaluating this function at 2. So I would say 3 times 2 squared plus 7 times 2 minus 20. And so what we would do is we would end up with, in our next line, 2 squared is 4 times 3 is 12, plus 14 minus 20. So we have 26 minus 20, or we have 6. So what does that mean? That means that the remainder would be 6. How could I prove and verify that? Do the math. So the formality will throw you off a little bit. So I'm trying to avoid it just a little bit for today, and we'll come back and look at it again. So what we're saying is if I crank through all this math, I don't care about what this is. When I'm done, I should have a remainder of 6, right? That's what I should have when I'm done, is I should have a remainder of 6. So what do I multiply x by to get 3x squared? 3x. 3x times 2 is negative 6x. 3x times x is 3x squared. Now I'm going to change the sign, so this becomes negative, this becomes positive. These cancel, and I have 13x minus 20. What do I multiply x by to get 13x? 13, right? So I'm going to say positive 13, and 3 times 2 is negative 26. 13 times x is 13x. Then I change the signs. These cancel, and look what I'm left with. That's no accident. Okay? Does that make sense? Now, when you think about it, what they're really doing is they're saying that because this is a solution and we set it equal to 0, we should be able, if it's a solution, if we plug that in and we work backwards, we should get the remainder of 6. Does that make sense to you guys? There's a little more formality to that. But just follow the algorithm for now, and then after, when we go to the next section, we'll talk more about that and we'll expand on that. We're actually, when we start to talk about synthetic division is based on this very principle. Okay? To look at it mathematically, just I want to try one more thing, so it kind of to prep you for the synthetic division. If I were to say, well, it's difficult to do without the variable, so we'll just leave it at that for now.